Dear students, you are welcome in this class. Today we are going to discuss the methodological interpretation of fertilizer experiment. This is topic number 1, and you must be wondering that what does it mean methodological interpretation of the fertilizer experiment. Here, friends, you know that in case of fertilizer, the nutrients are supplied by the fertilizers. You must be knowing that farmers apply fertilizer to supply the nutrients. And these nutrients are necessary for growth of the plant. And then in fertilizer, you want to increase the efficiency of the fertilizer. Fertilizer have many good things and many bad things. So good thing is that fertilizer are sources of the nutrient. And another good thing is that they have been very, very important in ensuring the food security in India or many other countries. Without fertilizer, it was not possible. Many times people say that it is about more than 50% contribution in food security or in food grain production has come from fertilizer. Besides, you have varieties, machinery, pesticide, and so on, and irrigation also. But role of fertilizer has been very, very immense in securing food. Another third point, first point I told you about fertilizer, that they are source of nutrient. Second point, I told you they are essential or they had been necessary for food security. And number 3, indirectly, fertilizers have saved our land. If fertilizers were not there and we wanted to increase our food production, then we could have cleared more forest area we could have cleared to get more food production. Means we could have spread horizontally. We could have found more land under food grain production. So therefore, because fertilizer will increase the productivity, so from less land, we could produce more food. So that is why these 3 important roles are there that are important for in favor of fertilizers. Against also, you will see that fertilizers have been misused. Many times they have particularly imbalanced fertilization. Imbalanced fertilization, you use more of nitrogen and less of phosphorus, potassium, and other nutrients. So imbalanced nutrition means in favor of nitrogen. So nitrogen pollution will be there. Excessive nitrogen application can also result in decreased quality of the grains. And it can result in the lodging of the grain, lodging of the crops. You must have seen these days, wheat lodging, mustard lodging, many crops have lodged. So excess application of nitrogen has been a matter of concern, and it pollutes water, it pollutes air, and it pollutes your environment overall. So fertilizer have negatives and positives. So what can be done? We cannot survive without fertilizer because it is necessary. But on the other hand, it is causing pollution. So what option is left? Option is that go for efficient use of fertilizer so that minimum best wastage is there and we get the best use of fertilizers. So in this case, overall, we should increase the efficiency of fertilizer use. Efficiency of fertilizer use can be manipulated, can be increased by different approaches, by controlling climatic or weather factors, by controlling plant factors, by controlling soil factors, and by controlling fertilizer factors. I told you 4 factors. Number 1 is climatic factors. Number 2 is plant factors. Number 3 is soil factor. And number 4 is fertilizer factor itself. So if you want to improve efficiency of the fertilizer, besides controlling climatic, soil, and plant factor, you should also consider fertilizer factors. Here, fertilizer factors means 4R. 4R means your right time, right method, right source, right dose. So right quantity is important. Right time of application, method of application is also important. So, and source of fertilizer. So in these, you see the right amount of fertilizer is very, very important, which can improve the efficiency of the fertilizer. Now, to know the right amount of fertilizer, optimum amount of fertilizer, you need to conduct certain field experiment. Finally, field experiments are required to be conducted to know the optimum requirement of fertilizer. So therefore, there are different methods which are used for interpretation of fertilizer experiments. So one method is calculation of nutrient use efficiencies. Other method is you can you can do the cost benefit analysis, complete cost of production and additional cost or additional money spent on fertilizer. And you also have data on revenues, how much money you can get from that output, and do economic calculation. You can work out benefit cost ratio also. So that is one way. Another way is that you can interpret the fertilizer experiments through response curve fitting. Response curve fitting is also there. Today we will discuss how this response curve fitting can help to identify the optimum doses of the fertilizer. And to know the response curve fitting, one must have idea of this correlation and regression. If you have idea of correlation and regression analysis, then response curve fitting will become easier. So today you will also see how we can go for response curve fitting. So this is the subject of this lecture, and hope you will concentrate very seriously on this. If you miss one point, you will not be able to understand next points. So therefore, I seek your attention, and you can stop me whenever you have doubt, you want clarity, you just stop me. I will clarify that point. Now, for references, I have already given you statistical procedure for agriculture research by Gomez and Gomez book. In this book, you have one chapter on correlation and regression. So kindly you see that chapter, very good chapter written on the subject. Only one chapter you need to read from Gomez and Gomez. Otherwise, yesterday I sent you some chapters from important books on linear relationship or on correlation and regression. So you can see those one also. One important book is there, Estimating Fertilizer Requirements. This book may not be available to you, but this is dedicated to this subject. Other is Soil Fertility Evaluation and Control, CA Black book. I have already supplied this book to you. Now, overall, what you will see here is fitting of response curves. What is response curve and what is meant by fitting of response curve? And then, as I told you, that response curves fitting is based on knowledge of correlation and regression analysis. So we will see the difference in correlation and regression, and there may be different kind of regression analysis or equations that may be linear, quadratic, cubic, polynomial, and so on. And here I wish to say you that equations, models, and curves, they have almost same meaning. People use them interchangeably also. Equation where you will have some relationship between different variables, and it can also be called as a model. Now these days people call model or modeling. And same equation can be plotted. If you know the relationship between two variables, then you can know the coordinates, you can know the values, and make a curve out of that data, out of that equation. So same equation can be represented graphically also. Therefore, it will be a curve. When the same equation is represented graphically in the form of a graph or line, then it becomes a curve. So therefore, don't get confused in equation, model, and curves. And once you have fitted the response equation, you will be able to identify the best dose, the optimum dose of fertilizer. And there are many other uses of response curves. So you will know the other uses of response curves and how, interestingly, you are not in physical mode. Otherwise, I could have shown you right on the computer. So you will use Excel to fit the response curves, to know the correlation and regression analysis. It can be done in Excel also. In the third or fourth lecture, I will train you in using Excel for response curve fitting. Then once you have fitted the curve, you have found the relationship, then interpretation of the results is also important. So this you will learn, and finding the best response curve. So which model can represent a particular set of data more appropriately. So this is all we are going to discuss. Any point you want to raise at this moment? Anyway, I start. So as discussed before also, factors of plant growth, you see yield. Yield depends upon growth. I discussed in detail, and then you got yield. And yield, you want economic returns. You want more returns. Here there are so many factors, and take nutrients as a factor or fertilizer as a factor of growth. Then you want to get more and more yields, and these factors affect the yield. Therefore, fertilizer or nutrient supply is important growth factors, and you want the optimum level of fertilizers. So now optimum, how to decide that how much fertilizer or how much nutrient should I apply to my crop? So here I kindly consider nutrient supply or fertilizer supply for the time being in this lecture as equivalent. If I say fertilizer requirement, you can consider it as nutrient requirement also. So how much fertilizer or how much nutrient, a particular nutrient, should be supplied to get the optimum growth so that you get maximum return? That is the question. So how I can identify that how much fertilizer or nutrient supply should I make? So can I do it based upon visual plant diagnosis? If you see crops, deficiency symptoms are there. And based upon those deficiency symptoms, you can find out, okay, this particular crop is deficient in phosphorus. Okay, you will find, but you do not know how much fertilizer or how much phosphorus should I supply to overcome this deficiency or this shortage. So therefore, visual plant diagnosis is not of much use in deciding the quantity of fertilizer to be applied. Number two, okay, if visual plant diagnosis is not good, I will do the plant tissue test. Qualitative tests are there that also indicate the medium, low, or high level of nutrient in different plant tissues. These qualitative tests are used. They are not quantitative. They just indicate whether a plant is deficient or sufficient in a particular nutrient. And then based upon the plant tissue test, you cannot decide the quantity of fertilizer. Okay, this will not work. It will just give you some indication, some idea that a plant is deficient in a particular nutrient. Okay, now I will go for quantitative analysis, plant chemical analysis. I will know the concentration of the different nutrients in different plant parts and see the deficiency. Okay, I did it. I found that in rice at tilling stage, my plants have 1% nitrogen. Shoots have 1% nitrogen at tilling stage. Okay, I know that this is deficient. I know this is deficient, but I do not know, based upon this information, I cannot decide the quantity of the nutrients or quantity of the fertilizer. And once I have done the quantitative analysis, once we know the status or concentration of nutrients in different plant tissues, then we can fix the critical values. Critical values, okay, this is the critical value in soil, critical value in plant. So these critical values of nutrients are with respect to content in soil as well as with respect to their content in plant parts. So critical values are available. Okay, if a nutrient is below the critical level, then how much nutrient should I apply? I cannot know from even the critical values how much nutrient should be applied. Then what else is left? Okay, I will go for soil chemical analysis. I will test the soil for NPK, carbon, pH, whatsoever parameters you like. You can do the soil chemical analysis, soil testing, and you will know the status of the nutrients. So if you know the test values, soil test values, can you recommend the quantity of the nutrients? This is question from students, particularly from soil science. If you know the soil test results, that okay, this much is N, this much is P, this much is K, or micronutrients, then can we recommend the quantity? Can we tell that how much quantity of fertilizer should be applied?
Yes, sir.
Okay, how we decide? What are the principles of deciding the nutrient application rate? Recommendation?
Sir, one is that critical value, and we also know some tabular value that about the optimum amount of nitrogen, phosphorus, or potassium and other nutrient. So if we determine the soil nutrient, then we can compare and tell them about how much to apply.
So actually, good. Actually, here I want to tell you that it is not possible to recommend the exact quantity of nutrients only based upon the soil testing. You must know the response of the crop, because the uptake of nutrients, the supply of nutrients is governed by several factors like soil type, kind of crop you are growing, water relations, climatic factors. So what happens that so merely this soil testing is not enough. Those are very general recommendation that if your nutrient level is high, you don't apply. If it is medium, apply that much. If it is low, so those are very vague recommendation. They are not really good recommendations, but still there are some deficiencies in those kind of recommendations based upon just soil testing. So what next can be done? We can go for pot experiment. They are also not enough, because the condition of pot is different from the soil condition. The dynamics, the behavior of nitrogen or phosphorus will be different under pot condition as compared to the field conditions. So, okay, these pot experiments are good, or sand cultures or some greenhouse experiments are good to see the deficiency and toxicity symptoms of the nutrient. But so far, recommendation is concerned how much nutrient supply should be made. This is to be decided by field experiment. So finally, my purpose was come to the field experiment. So in the end, you need to test the response of the fertilizers in under the field condition in varying fertility. If your fertility is varying, then how much nutrient will be, what response you will get under different conditions, and then based upon this, you can give the recommendations. Because these field experiments or fertilizer experiments under field condition is the final answer that will tell us how much quantity of nutrient is optimum that should be supplied to the crop to get maximum benefits. Hope this is clear to you. Now, critical value, just to make little understanding of the critical value, it is the level of concentration of a nutrient in the plant or soil that is likely to result in 90% of the maximum yield. So this is critical level, and this can be for deficiency as well as for toxicity. Toxicity also, you have some critical levels, particularly in case of certain micronutrients, iron, manganese, zinc, copper, boron, etc. So you have some critical levels for toxicity as well as for deficiency. So level, that particular level of nutrient, either in soil or in plant, where you get 10% reduction in the growth or yield of the crop, that particular level is critical level. Maybe for deficiency, it is the lower side, and toxicity, it is higher side. So that is your critical level of nutrient. Any doubt? Now you see this picture, try to understand this picture about the toxicity and deficiency. So you can see on x-axis, you have concentration of the nutrient in plant or in soil. So on x-axis, on the right side, if you move, it is increasing. And if you see on y-axis, it is represented by increasing growth or yield. These are relative growth or relative yield, you can see. So initially, the deficiency of nutrient is there. Somebody's mic is on, kindly put it off. So as you move from left to right on the x-axis, initially the nutrient is very, very deficient. So here you get acute deficiency. The growth is hardly 60-70%. You see here, this is the growth. And if you still increase the supply in soil or plant, then it is latent or hidden deficiency. It may show or may not show the deficiency symptoms in this zone. And in this zone lies the critical value here. So critical value means you are getting about 90% growth, 10% growth reduction is there, or yield reduction is there. So at this particular point, whatever level or concentration of nutrient is there in the plant or soil, where you are getting 90% of the maximum possible yield, it is known as critical concentration of nutrient in soil or plant. You still increase the supply, and then one region will come where you will get the optimal supply. here in this zone, and here you are getting almost 100%. Of course, some luxury consumption may be there in case of potassium, and still you will get 100%. This luxury consumption of potassium will not decrease the yield here. That is why it is luxury consumption. It is extra consumption. And you still increase the concentration of the nutrient. Particularly, this is true in case of micronutrients. Then you can have light toxicity. You still increase the level, then it is acute toxicity. So somewhere here, wherever the 10% is 10% reduction is there in the yield or growth due to increased nutrient supply. So where you get 10% reduction in growth, this point will be critical value for toxicity of a nutrient. So this is just to show you what is critical value. So just if you know the critical value of nutrient either in soil or plant, you cannot decide the exact quantity of the nutrient to be supplied. Now you see these are the critical values of different nutrients in soil and plant. So for zinc, for example, it is 0.6 ppm in soil. In plant, it is 10 to 20 ppm critical value for deficiency. And for iron, you can see, so you can go through this data on critical values. This I can skip. There are different methods for evaluation of soil fertility, like visual plant diagnosis. I have discussed plant analysis. You get rapid tissue, total plant analysis, soil testing. These I have already discussed, need not to discuss. So what I told you in the end, that you need to conduct field experiment for interpretation of fertilizer to know the response of the fertilizers. So ultimately, this is the best way to recommend the nutrients. So what you are required to do here is steps in interpretation of results obtained by conducting fertilizer experiments. Most of the students in agronomy and soil science for last many decades are working on this subject. They take different sources of fertilizer, they take different doses of fertilizer, they take different time of application, method of application, and so on. And then they conduct the experiment on different aspects of the fertilizer. Here just we are concentrating only on doses of fertilizer application or doses of nutrient supply. You are conducting field experiments and you will get some results. You will have different levels of fertilizer, say 0, 20, 40, 80, whatsoever, and then respective yields will be recorded. Yield at 20 kg, yield at 60 kg, yield at 100 kg. You will record the yields. So now you have X is fertilizer rate, and Y is your yield or response, how much yield you are getting, how in terms of grain yield or whatsoever is there. So now you have one is independent variable, that is X fertilizer, and other is yield. Now you want, first you will test the significance. First you will see the F test, ANOVA, analysis of variance. You will see whether the fertilizer is influencing the yield significantly or not, or at what level you are getting, up to what level you are getting the response. So you do the F test. If your results are significant, if your F test is significant, then you need to do correlation and regression analysis. If your results are insignificant, non-significant, then you stop there. You need not to go further for correlation and regression analysis. But if your fertilizer response is significant, then you can go for correlation and regression analysis. And the procedure is called as response curve fitting. On response curve fitting, by having the knowledge of correlation and regression analysis, I can fit a curve. I can find a curve which is known as response curve fitting. I will discuss in detail what is response curve fitting. And once you have found out a response curve, which is relationship between input and output, it is just like a production function where you also had relationship between input and output. So here also you will have some kind of relationship between fertilizer and yield. And you will make that relationship in the form of an equation, and that can be converted or represented in terms of graph. So then you will see this in detail, response curve fitting. And after fitting the curve, means after you find out the equation or curve, then you can go for economic analysis to decide the optimum dose of the fertilizer. So this is how this subject will revolve around these. So before I start this response curve, do you have any question, any doubt in your mind in these fertilizer?
Yes, sir.
Yes, please.
सर रिजल्ट सर सिग्निफिकेंट सर वो कैसे चेक करेंगे वो वाला डाउट है सर वो
Actually,
बाद में बता जाएगा
no. Actually, are you studying any course on experimental design?
नो सर
You have no idea, I think. In experimental, in BSc AG, you are taught measures of dispersion, mean, median, mode, and simple. So what happens?
yes sir that was
What happens in the beginning when you do fertilizer experiment? We need to have some. We need to decide the design of the experiment. There are different design, maybe 100 kind of designs are there, but important one are randomized block design. RBD is the most frequently used design in agricultural research in field conditions. So randomized block design, which is also factorial. Sometimes if you have more than one factor, it is factorial randomized block design, factorial RBD or simple RBD. We also have strip plot design, and we also have sometimes Latin square design, or number of designs are there. Suppose it is randomized block design, and in randomized block design or any such designs, you have some fundamental principles, which is known as your replication, randomization, and local control. You must be knowing the basic principles of statistical design. So these are the three fundamental principles based upon which you lay out an experiment. In this experiment, suppose you will have 3 replication and 10 different levels of fertilizer, and treatments are randomized. You will grow the crop, you will harvest the crop. For every treatment or every fertilizer dose in different replications, you will record the data, record the yield. Suppose yield. However, most of the time you record the dry matter production, leaf area, plant height, so many things are recorded. Assume that you have recorded just yield. So now you want to test the significance, whether this yield is genuinely influenced. You will have one hypothesis, H0. H0 means this hypothesis will of no difference. You will say, okay, the fertilizer doses do not affect the grain yield or the grain yield. And you will have alternate hypothesis H1. Okay, it will affect the yield. So normally H0 is rejected in this case, and F test is conducted. F test, you may be knowing, which is ANOVA, analysis of variance. The variance in yield due to fertilizer will be broken into different components, different sources. One is replication, other is your treatment itself, and then third source of variation will be error. So these are the sources of variance, and then F test will tell you whether the treatment differences are significant or not. So that is F test or ANOVA, analysis of value. So if your results are significant, here meaning is results of the test, F test, are significant, then you can go for correlation and regression analysis. If results are non-significant, that means the fertilizer doses are not having any significant effect. Means response to fertilizer is not there. Is it clear?
Okay, sir. Yes, sir. Yes.
So try to see some statistics book. Okay, you will be taught about this experimental designs. Now we move forward. Now response curve. So response curve is your functional relationship between input and output will be a response equation. So this is also a kind of production function actually. This is a type of production function. Equation can be represented in graphical form also, that I told you it is response curve. So relationship between yield and fertilizer rate is fertilizer yield function. You can know the response with respect to seed rate also. You can have, it is not just fertilizer rates, you can have yield and your seed, yield and seed rate functions. Yield and seed rate functions. You can have different seed rates, say 10 kg, 20, 50, 100, and you can see the relationship to the yield. You can see the relationship between seed rate and the population, plant population. You can see the relationship between irrigation levels, 1 irrigation, 2 irrigation, 3 irrigation level to the yield. You can see the herbicide doses also. You can have relationship between herbicide doses and grain yield or yield. So variety of inputs can be correlated or can be response curves can be made with the variety of inputs. But the dependent variable, the inputs are independent variables. Whatever inputs you are using, those are X, those are independent variable, and the yield is dependent variable. Growth is dependent variable. Dry matter production is dependent variable. Leaf area index is dependent variable. So you need to see, you can have relationship between any dependent variable to the one independent variable or many independent variable. So this is how these response curves are made. Model estimated from experimental data will give a realistic mathematical representation of the biological relationship indicated by the data. So this will be called as a model or equation, where you have relationship, for example, y is equal to 2x or y is equal to 5x. So this is also a kind of relationship, and this can be converted in the form of graph also if you find the coordinates. So we will move to the next link. I can stop here. You can change your link. We continue with the topic response curve. Now you see type of response curve. See this carefully. In the first column, you have degree, name of the equation, name of the curve. This is response curve. These are response curve is relationship between dependent variable, that is y, and independent variable, that is x. So if it is first degree equation, y is equal to a plus bx, first degree equation means power of variable x is 1. Then it is linear. Equation will be called as linear, and the name of the curve is straight line. Here it will be a straight line. Second degree response curve, quadratic is the name of equation, and parabola is the shape of the curve. Then third degree response equation is your cubic, and the curve is cubic parabola. The name of the curve is cubic parabola. Fourth degree means x power 4 is highest. So this is called as quadratic. I think I need to check it. And then it will be a quadratic parabola. So on you can have, we mostly go up to the cubic relationship, third degree. A production functions or response function is a mathematical expression that describes the physical relationship. Here also, this response function is the equation actually. Equation, relationship between input and output. The relationship is expressed as y is equal to f into x1, x2, x3, and so on. There can be many independent variables that can affect one dependent variable. Now you see the different types or shapes of different response curves. One is linear.
Hello,
you can
sir.
see. Yeah, yes, please.
सर आपने जो बोला ना फर्स्ट डिग्री इक्वेशन y equals to mx plus c, that was a linear equation.
Y is equal to a plus bx is linear equation. Yes.
यस सर. इसके बाद सर सेकेंड डिग्री में जो आता है उसमें सर x का पावर टू द पावर 2 हो जाएगा, x स्क्वायर हो जाएगा.
हाँ, यस यू आर राइट. यस.
ओके सर, तो अगर हम x का एक वैल्यू पुट करें तो सर वो भी तो लिनियर ही होगा ना, पैराबोला कैसे होगा?
x का वैल्यू,
x का अगर कोई वैल्यू पुट करें हम तो उसका स्क्वायर, अगर x का वैल्यू 2 पुट करें और 3 पुट करें तो उसका स्क्वायर 9 और 4 होगा, तो 4 b प्लस c होगा, तो लिनियर ही होगा ना सर?
You actually, in case of you will see later, even in case of this quadratic equation, if you want to solve quadratic equation, first you need to linearize it. The linearization will be done for this quadratic equation or x power 2, and then only you will find the solution. You will get clarity later. You will get clarity later on this subject. Now see the types of response curves. This is linear relationship, linear curve. This is your quadratic, the shape. This is your cubic. This is your quartic. So that was quartic actually. This is fourth. Here it is quartic parabola. So there is mistake here. It is not quadratic. Quartic. So you get quartic, this kind of shape, and exponential regression is also there. This kind of shape, where it is increasing at increasing rate. So now types of equations or curves continues. So one is exponential equation. Normally there are two kind of equation in algebra. In exponential equation, the exponent here means power of something. The exponent or a part of the exponent is a variable. So exponent or variable itself is in power. Variable itself is a power. For example, 3 power x is equal to 81. This is one equation. So here you can see, so x is actually exponent. So such kind of equations are exponential equations. Then other equations are polynomial equations. So it is an expression consisting of variables x and y, coefficient b and c, exponents 1 and 2. So exponents are power, coefficients are multiplication to the variables, and variables are x and y. So here you can try to understand what is a polynomial, what is there in polynomial equation. So you have one dependent variable, that is y, one independent variable, that is x, and this independent variable will have different degrees of powers. It can have 1, it can have both 1 and 2, it can have 3 also. You go on adding this. So this is your polynomial equation. So y is dependent variable, x is independent variable with degrees 1 and 2, and highest degree is 2. So name of the equation will come from the highest degree. If highest degree is 2, then it is quadratic. If highest degree in equation is 3, then it is cubic, and so on. But it will have equal number of terms also. Suppose if it is 3, then you will have 4 terms. A is also there, bx, cx, and dx cube. So these are just for basic understanding. I assume that you know it already, polynomial equation, because these are taught in 8th class, 6th class. You remember, if you recall, you used to solve these equations, values of x, values of y, and so on. You already done it on graph paper also. I don't know, but we did it. When we were in 6th or 7th standard, we would solve these quadratic equations and learn the plotting of coordinates on graph. You will have 4 quarters, plus, plus, minus, plus, minus, minus, and plus, minus. So likewise, if you recall your days. So exponents in P here is polynomial equation. So exponents in P polynomial equation can only be positive integers. They can only be positive numbers, 1, 2, 3, 4, etc. Negative integer component is never a part of polynomial equation. In polynomial equation, you will not have negative exponent. The independent variable, that is x, can occur multiple times. Like in last case also, you have seen it can occur multiple times. Different x's are separated by addition, subtraction, or multiplication. Normally, you will see plus or minus signs are there. The degree of polynomial is highest degree of the exponent that exists in the equation. The equation will be known by the degree of the variable, highest degree of the variable. Now you see polynomial of degree 0, no relationship. Means here there is no regression variable. A polynomial of degree 1 for linear or straight line, polynomial of degree 2 for quadratic type of curved relationship. Curved relationship. It is not a straight line. Y is equal to a plus bx plus cx square. Dear students, please remember that in quadratic equation, it is always plus, plus, plus. All are plus. It is never minus. Many times students do mistake. They write y is equal to a plus bx minus cx square, which is wrong. Minus, actually in the equation, minus is not there. But when you fit the equation, sometimes you will find value of this C in minus. Therefore, you will find in some answers, you will find minus value, but equation as such is fully positive. There is no negative sign in these equations, any of these equations, polynomial equations. Polynomial of degree 3 for cubic type of curved relationship. Curved relationship are also called as non-linear relationship. So y is equal to a plus bx plus cx plus dx cube. This is your polynomial of degree 3. Here you can see 4 terms, 1, 2, 3, 4. 4 things are there. Polynomial of nth degree, say 4, 5, 6, 7, 8. You can write like this. This can be written like b0. b0 is equivalent to a plus b1x, b2x square, b3x cube, and bnxn. So this is a typical polynomial equation. We continue. The polynomial of degree 1 is a linear response, is a straight line. I'm just repeating it again and again so that you get better understanding of the things. Just taking them from all the angles. Polynomials of degree 1 is a straight line, but 2, 3, 4, 5 degrees are there. This kind of relationship is curvilinear relationship, as he was saying, curvilinear or non-linear in nature, representing a version of the law of diminishing return. You will find later on this curve, quadratic curve particularly shows law of diminishing return kind of shape. Economic interpretation are made from these functions. So if you have quadratic or curvilinear functions, then you can do some economic interpretation like having the optimum dose of the fertilizer. Procedure for fitting different response functions to experimental data are available. And those procedure you will learn today. Not today, but in subsequent lectures. Procedure for applying economic principles to experimental data via different response functions generally worked out by the individuals or the person who have interest in these kind of functions can develop these kind of relationship. The linear response implies constant returns. This is true because with the increase in this X or independent value or increase in the input will result every time same output. Every time it will give you additional unit will give you same additional output. That is your constant return. In curvilinear, initially, just like law of diminishing return, you can get increasing return, then decreasing return, and finally you can get negative return. So therefore, sometimes in equation, I was saying that value of C is in minus because there you may get negative returns. So now question comes, how to develop this relationship? How to find out the relationship between input and output? Here input is fertilizer, independent variable, and output is your grain yield or yield of any kind. So suppose you have conducted a field experiment, your data was significant, F-test was significant. Now you have data with you and you want to go for response curve fitting. A linear kind of curve, just begin with linear relationship. So here, how can we do it? How to go for response curve fitting? What does it mean, response curve fitting? Now you will see it. We have conducted a field experiment where we had different levels of fertilizer. On x-axis, you can see different levels of fertilizer or nutrient, 30, 60, 90, 120 kg per hectare, and so on. So for every fertilizer level, you must have recorded the yield, respective yield, whatsoever is there. It is just to show you. Suppose at 0 level, you got certain yield, say 3 tons. At 30, you got this much or more than 5. At 60, you got this much of yield. At 90, you got this much. At every level of nutrient, you got some yield. And you got some yield that has been recorded by you from the field by conducting the experiment. And these are the yields, and these are average value, mean grain yield. You can take the mean grain yield. You have 3 replications, take the average of those yield and plot it. You can plot it easily on a graph paper, or you can plot it on a computer also. So these are different points. These are different points or response or yield at different levels of a nutrient. Now question come, can we join these points? Can we make a line by joining these points? Can we make a curve by joining these points? This point to this point, this point, this point, this point, this point, this point. Can we join these points? So mathematically or statistically, we cannot join these points. Because say we know what yield is there, what response is there at 30 kg. At 30 kg, we have recorded this much of response. At 60, we have recorded this much of response. But we don't know what will happen if I apply 40 kg. If I apply 50 kg, I will not, I do not know. I have not recorded this data. So how can I join these 2 points? If I join these 2 points, then I will know how much yield was there, how much response was there at 40, 50, or at any level between 30 and 60. So here, I'm not authorized to make predictions. I cannot predict the yields for the data or for the value of X, where I have not recorded or where I do not have the actual data from the field. So what can I do? What should I do under these circumstances? So, okay, now I cannot join this point to make a line, but I can make a line. I can develop a line. I can find a line that can represent all these data, that can represent all these data, that can fit this data, that can fit this data, that can fit this data. So this is just like cloth. A tailor, I have some cloth. I have taken that cloth to the tailor, and I have asked the tailor, okay, stitch a shirt, make my shirt from this cloth. What tailor will do? He will take my measurements. He will take my arm length. He will take my chest. He will take my collar, and everywhere he will make measurements. Have you seen tailor? I think now you are buying the ready-made shirts. But if you go to a tailor to get your shirt stitched, he will take measurements. So likewise, suppose these data represent your body, your shape, your length, your height, breadth, etc. These data represent. And then he is taking the measurement. He is measuring the distances, and he will find the best fit that is very tight to your body. You will ask him, make very tight fit of this. So here also, you want a line that can be very tight, that can pass through all the data as close as possible. That line should pass as close as possible to these data so that you get the best fit. So here, response curve fitting means to find a curve that will represent this data the best, the most best. That is known as response curve fitting. You are just going to make a fit curve that represents this data the best. So therefore, this is called as response curve fitting. Now, how to do it actually? How to do it? That is the question. Now, response curve fitting is clear to you. We need to find a line. We need to develop an equation or line that represents this data, and that will be kind of imaginary line. And that line will be used to make the predictions, because predictions cannot be made by joining these points, by joining the original data. And you can see that this data can be represented by several lines. This is the shape of the data you can see. So you can draw several lines, but which line will represent this data the best? How could I know it? How can I know it? That which line will represent this data best? So to do this, we go for method of least square. Method of least square is used to fit this curve. So no straight line passes exactly all the points, although many can be drawn. Here you can see many lines can be drawn, but no line will exactly, straight line will exactly pass through the data. Here we are dealing with a straight line. Find a straight line which fits all points better than all. We need to find the best fit line. In other languages, what value of A and B in equation must we know? If we know the value of A and B in the equation and the procedure to know the value of A and B, we can find the best fit line. This job has been already done by a statistician for us, for our help. Okay, you have equation, linear equation is y is equal to a plus bx, and the statistician also told us to find out the value of a and b. These are the constant. If we find out value of a and b, that particular equation will result in the best fit. So we need to find out the value of a and b. You will understand later. Can we devise a measure of all closeness of the fit of the various lines which can be drawn? We can see that which line is more closer or closest. It is also possible that data follow the diminishing kind of curve. So sometimes it is not necessary that you will fit a straight line. Sometimes the data will ask you to fit a curvilinear kind of relationship, maybe quadratic relationship. The response curve are fitted by using method of least square. So method of least square is used to fit the curve. That means to find out the value of A and B, you should use method of least square for response curve fitting or best curve fitting. It is also called as best curve fitting, which represent this data very well. Now the method of least squares. It is a statistical method used to determine a line of best fit that fit that data, original data or actual data well by minimizing the sum of squares created by a mathematical function. So you need to minimize the sum of square of distances actually from the original data or actual data. And it is squared because some values will be minus, some values will be plus. Therefore, you need to square the distances from the predicted line. A square is determined by squaring the distance between a data point and the regression line. Regression line is actually your curve. So now you see just few minutes, 2-3 minutes only. So now the method of least square, you can see, suppose this is your data and assume that this is my predicted line, the curve you have fitted it. Suppose in another case also you have fitted this curve, this line. You decide that this is my best line. In the third case also, you decide that this is my best line. But how can I know that which one is the best fit? Which one is best representing this data? So what is to be done? Actually, we need to measure the distances. Suppose this data, and this is your line. Suppose assume this is your line, and then the distance between this data point and this data point, and then distance between this data point, and distance between these. So some values you will get negative because some values are lower than this. So if you deduct, this is suppose your actual data, this is your predicted line. So if you take the difference between these two, here it will be positive. But here, if below the line, data is below the line, then difference may be negative. So you square those values and take the total of, now you need to square these values because some are in negative, some are in positive. Many times if you take the total of this, it will become 0. So therefore you need to square these values and make the total of all the squares for respective data. And in this case also, you need to work out the squares of distances. In this case also, so the graph or the line which is giving the lowest value of this sum of square of distances is the best line fit, which is called as method of least square. I may continue in the next class because now your time is over. I will continue to explain you the method of least squares. And this ends here. And you can reserve your questions for the next class. And this is really very interesting topic. And I want that each one of you is able to learn this topic and use in your thesis also. This knowledge can be very well used in your thesis and paper writing, etc. Now it is time for attendance. I can take your attendance. So actually, this is a very interesting subject. And if you, I gave you some notes. If you read those notes on linear relationship, correlation analysis, this is very, very interesting and very, very useful subject. And I can clear all kind of doubts related to this. Modern day modeling is based upon correlation, regression analysis. and this is really wonderful subject, and it will be taught to you in IESRA also. But difference in IESRA is that they will teach you only from the perspective of statistics. If you go to farm management, they will teach this subject from the perspective of, say, economics. But here, what we are doing here, we are blending three subjects: statistics, agronomy means crop production, and your economics together. Then it gives you complete package of the subject, complete idea of the subject. Therefore, it is important from this angle also, how best we can combine three different subjects of statistics, economics, and agronomy or crop production. And for this, you must read, you should read more and more what I gave to you. And if you, next time, whenever we get a chance, you will have very good idea of this subject. So I must thank you. Thank you very much. See you sometimes by the end of next week. Thank you. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you.
Sir.
Thank you very much.
Today extra class.